Kane is in the building, nigga.
Did I do that?
What's good, Budget Buds? We're back at it yet again. So, in this episode, we're going to be covering autoflowers and how to make the best possible autoflower genetics. I mainly wanted to do this video before the seed ban because there is an incoming seed ban in about 4 months, roughly. Starting November, we will no longer be able to federally ship seeds anywhere, which is part of the reason why you haven't seen me on here. Kind of struggling with the idea that I spent a lot of time creating a channel solely trying to give seeds away for free. And now it's going to be illegal to do that. So let's talk about how to make your own best possible autoflower genetics. And in this video, I'm going to be talking about things that might be a little bit in depth for the average grower. So the target audience for this might be more leaning towards breeders or content creators. So first things first, I want to cover Lowryder genetics. I might talk about FINOLA, and I might touch on Iranian cannabis by the end of it. But we're mainly focusing on Lowryder genes today in this episode. Let's get into it. Beep, and then the little video cut.
How
and then
about
like,
you?
I might just do this like a one shot. So, anyways, with autoflowers we have today in modern genetics, we see that almost all autoflowers originate from Lowryder genes. Originally, we thought Lowryder genes were a recessive gene, but by combining Lowryder with photoperiod genetics, we've created fast flowers. This trait would let us know that the gene is not entirely silenced. If you have one copy of a autoflowering gene, you will have some effect on the flowering time and speed. Specifically, now we know it lowers the bar required to flip on the switch to flower, to produce phlorogen. We know the exact location, actually. We've even named it. It's called Autoflower 1, aptly named. It is located on chromosome 1. So what this means for us is if we did genetic analysis, we could find any plant that has a genetic marker to be an autoflower. That's cool. We know that's incomplete dominant because the effect is not entirely silenced if there's only one copy. We even know the mechanics. So 14 hours, 13.5 to 14 hours is roughly what they need to start flowering, which is way more than the 12 hours. So you can easily filter the plants using daylight hours. So now that we know the mechanics of how to filter for a plant with the gene, we know the gene location, I'm going to explain what the gene is. The gene is CS for cannabis sativa, PRR37. It's a pseudo response regulator. What it does, it acts as a brake pad to tell the plant to stop your mechanical, your normal biological functions until the lighting hours drop to a certain point. And that point is 12 hours for most plants. With Autoflower 1, it's actually a broken gene. So autoflowers don't have a normally functioning gene. They call it a single nucleotide polymorphism. So one little letter change causes this protein to no longer function properly. It no longer inhibits phlorogen production properly. So moving on from autoflower genetics from Lowryder, there's FINOLA. I'm only going to briefly talk about these. I'll do a separate video on each one of these. FINOLA has a different mutation on a different chromosome that does essentially the same thing using a different function completely. It is a duplication of the phlorogen production gene rather than a malfunction of the brakes. It just shoots so much florogen that the plant wants to flower no matter what. This gene is a dominant gene. This is completely different from the gene that we have all worked with in modern cannabis. Anything that you see with the autoflower title in seeds and genetics, it's almost 100% chance it came from Lowryder. You can create autoflowers using F1s if you were to use FINOLA. Alrighty, so that gene was named Autoflower 2, and it's located on chromosome 8. Chromosome 1 over here on the other side has Autoflower 1. And as promised, I'll tell you about the third one now. Jade Nectar was one of the first content creators to ever observe this phenomenon. He had an Iranian landrace straight from Iran. I don't know how he sourced it, flew out there, came back, had the seeds from a long time ago. There was a study done in 2025, and the analysis was finished in 2026 May, so like just 2 months ago. They discovered that there is another autoflowering gene, Autoflower 3, and it's tied to Iranian land races. Jade Nectar was right all along, which is why I told you guys to watch his videos. I told you you'd learn something. I very rarely learn something from people, but he made me learn something. So he was proven right. Super glad that all the commenters who said, that's just autoflowers. No. There's actually 3 different autoflowering genes from 3 different locations. So we have FINOLA in Finland, which technically originated in Russia. Lowryder, which originated in Russia. And we also have Iranian land races. All 3 evolved separately, different mutations, to ignore the photoperiod so that they can produce flowers and seeds in time. Because there were selection pressures in places like Iran, which would get really dry, or Finland, where there was long days, and in Russia, where it was super temperate, super cold, you barely had any daylight hours, barely any. So all these autoflowers evolved different mechanisms that reach the same goal. In genetics, we call that convergent evolution. 3 different plants, 3 different places, same goal. Pretty cool. What does that mean for the normal grower? Not too much unless you get your hands on some Iranian landrace or FINOLA, because both those avenues to creating autoflowers is A, more direct, and B, very likely to be better than Lowryder. Alrighty, so now that we've covered the better paths, what's the best path that you have access to? Because you don't have access to FINOLA or Iranian landrace genetics, then what's the best path that you have? First, you need to get a keeper pheno of a photoperiod. You want a photoperiod that you want to turn into an auto, essentially. You want a photo that has maybe slightly longer flower times, but is really potent, absolutely perfect for whatever you want the application to be. Wash, yield, terps, whatever. Whatever your target is, get the perfect cultivar. Then you get a auto. Get the closest thing possible. If you're looking for a GMO, try to get a GMO auto. Oh no, my mic just died there. Hopefully it's not permanently dead. Okay, we're good. Oh, good. We're good. Keep going. You get the best possible auto cultivar that you can. And you would cross those. And there would be your fast flowering, your F1s. These plants will carry one gene that's the unbroken break, and it'll carry one gene that is the broken break. The brake pad. These plants will all flower if you turn the light cycle to 14 hours of light, or 13 and a half. Some will be a little more iffy, but roughly at 14 hours of light, they'll all flip the flower instead of the usual 12. This line is useful, but the genetics is not refined enough. Half of the genetics came from this auto that you probably don't like the traits of. Your ideal cannabis specimen, which was the parent, we're going to need to back cross. So this takes more time than line breeding, which is straight line breeding down. Normally, most auto breeders will just take 2 offspring from this new cross, this F1, breed it down. We don't want to do that yet. We will need to do that in the future, but not at this point in time. At this point in time, what we want to do is get the gene pool to be almost entirely photo period genes. So the ideal cultivar. How we do that is we back cross. So we take the fast flowering individual, back cross it to the parent. What that does is it drops the ratio of offspring to 25% being fast flowering, but of those 25% fast flowering individuals, 75% of their gene pool will be photoperiod, because we're breeding more and more photoperiod into this fast flowering line. The offspring of the cross are 75% photogenetically, 25% autoflower. Of the seeds that you pop, a lot of the seeds will not be what you're looking for because you've crossed a photo back into a fast flowering individual. Most of the seeds will be essentially photoperiods. Only a small section of them, 25% roughly, will have the autoflowering genes, but more photoperiod genes than its parent, which was about 50-50. 50 photo, 50 auto. You could think of it like a dog. If you had a white dog and you had a black dog, if you bred the white dog with the black dog and the offspring came out, I'm not saying this is how it works. If the offspring came out right in the middle, gray, if you bred the gray dog towards the black dog, you will get more towards the darker side of fur. If you took the gray dog and bred it towards the white dog, you'll get lighter fur as you move towards that direction. Unless the genes are incomplete dominant, dominant, recessive. I'm not a dog expert, so it was just a visualization. Sorry for the poor analogy, guys. We're going to take that offspring, which is 75% photo, 25% auto, and back cross it into the 100% photo again. And we repeat that process for as long as we can. We'll isolate an individual that flowers faster than the rest because we know now that the recessive gene is actually incomplete dominant. It has some effect. The effect is changing the light cycle threshold, the threshold to flip to flower, from 12 hours to 14 hours. We have a mechanical way to filter for genetics now. Now that we understand all this, we can take this information and apply it. We know how to filter out which plant has autoflower genetics. That's amazing. And also, we found out how to get this plant to mainly have only just the autoflowering trait, but not any of the autoflowering cannabinoids yields negative effects. We want only the positive. That's how we isolate the gene. I'll talk about FINOLA and Iranian cannabis in another episode, but this should conclude the talk for how to get the best possible auto. I'll do a quick little summary. You take photo, cross it, best auto, you get a fast flowering, take the fast flowering, back cross it into the photo. That's all. You keep doing that a few times, searching for the only individuals that flower under 14 hours of light. That's all you have to do. And now you've found a plant that has the genes to create autoflowers without having to go fill the entire gene pool with autoflower genetics. With that fast flowering individual that's 90-something% photo and just only selected for that autoflowering gene, you would cross those together, and the offspring that have autoflowering traits completely Because at this point, if you take a heterozygous individual, something with only one gene, and cross it with itself, line breed down, you'll get autos. 25% of your offspring will have 2 copies of that gene. What that means is, at that point, you have autoflowers with almost entirely photoperiod genetics and only isolated the autoflowering gene on chromosome 1 named autoflower 1. That's the secret. Everybody who didn't know the secret, there's a secret. You don't breed down, you breed up first, then you breed down. Yeah, and from the population that is 90-something% photo, but has that single autoflowering gene, you cross 2 of those, self them however you want, boom. You have seeds that are fully auto with almost entirely photoperiod genetics. You've isolated the gene. And that can take many less cycles than starting to breed down. You don't want to breed downward. You want to breed up first, then down. All right, guys. Hopefully that helps breeders. As far as growers, at least you know if you got a fast flowering seed, you can change the light cycle to 14 hours of light to maximize your DLI better. And if there's any of this stuff, any of these terms you don't know, hopefully you Googled them and rewatch this video. Love you guys. I'm out.